Hey, my name is Luke Hammock, and I went to the lecture on November 17th about the physics of genes and personalized medicine. Here, the speaker talked about DNA sequencing and the physics of DNA sequencing and how it applies today, how it's useful. A couple of the ways that it's useful. Sequencing DNA could be the key to finding cures for diseases, cancer, the causes for genetic disorders. Could be could possibly help us with our food allergies. We could know what food not to eat, what food to eat, and it could also be the key to having personalized medicine. Medicine that is specifically based off of your DNA, not anyone else's or a general population, but yours. Some of the main points of the lecture. So the speaker talked about DNA in general to begin. It consists of four bases, or four types of bases: adenine, guanine, cytosine, and thymine. And these bases are arranged in a specific order, which encodes our traits. And he talked about how our DNA is similar to that of a chimpanzee. It's like very similar, and it's also similar to, of course, it's very similar to that of other humans. And he talked about, well, just how DNA varies among organisms. And the speaker also talked about the goals of DNA sequencing. And he said it would be great if we could have like a handheld device that could like sequence the DNA of our food, and it could tell us if we should eat it or if it would be bad for us. If we could also sequence our own DNA just like really quickly with a cheap device. He said like maybe $10 one day in the future. And we could have this technology available to all kinds of people throughout the world, and it would just revolutionize the health industry and just human health. And so one of the ways of getting there, so he's been working on nanopore DNA sequencing, which a nanopore is made, which is inserted into the lipid bilayer, and it attaches to an enzyme which has already grabbed a DNA double helix molecule, and there is a potential difference across the lipid bilayer which allows a current to pass through the nanopore, and this also attracts the DNA molecule to come through the nanopore. And so this enzyme puts one strand of the DNA through the nanopore at a time, and it puts one base in at a time. And so each base will hinder the current passing through the nanopore differently. And each base passes through the nanopore at a certain rate, and because we can distinguish between each base, and this all happens because each of the bases are differently charged, and this is part of the physics of the DNA sequencing. And so each base will go through, and we can sequence the entire DNA molecule, and it takes very little time comparatively to do this. So he's been working on this technology. Now, after the lecture, I went back and I looked up how did this all start. I wanted to know a big picture of how DNA sequencing started. So Ray Wu was the first guy to come up with a way to sequence a DNA strand in 1970, and he used the primer extension method. which an RNA strand will have a complementary DNA strand synthesized on it, and then the two strands are separated. The DNA strand then undergoes electrophoresis, which separates the nucleotide bases based off of their charges by using an electric field and passing the bases through a gel. And based off of their charge, they will travel a certain distance through the gel. And then we could look at the gel and read off the sequence. But this took a long time. And so the reason this new advancement of nanopore technology, or nanopore DNA sequencing, is so useful is it could be very cost efficient, very time efficient, and it could just lead to a breakthrough in this health industry. That's all. Thanks for watching.